A very good morning and a cool welcome to you, dear students, to your geography class. Today we will continue our lesson chapter 5, Winds, part 2. Now in the last class we learnt about what are winds, types of winds like planetary winds, easterlies, westerlies, polar winds, etc. Right? Well, today we are going to learn something more about local winds, sea breeze, land breeze, and seasonal winds in detail. So let's fly in these winds, alright? Come on. Local winds and examples. Local winds blow for a short duration of time and originate in specific regions over a limited area. Now these breezes are similar to the sea and land breezes, which we'll be learning later. Now examples of local winds are valley breeze and mountain breeze. What is valley breeze? It's a breeze that blows up the valleys or mountain slopes on clear days. Here you can see in this picture, it is blowing up. It's blowing up. This is called a valley breeze. It goes from the valley, it goes up the mountain. That's why it's called as valley breeze. Now in the morning, the air in the mountain top, here is mountain top, over here mountain top, warms quicker than the air in the valleys. Warm air rises and the cooler valley air moves up the mountain slopes to form a valley breeze. Here you can see the warm air rises up. Here also you can see the warm air is rising up and cooler valley breeze goes up the mountain. This is called as valley breeze. Now let's talk about the mountain breeze. Mountain breeze, it's a breeze that blows down a mountain slope due to the gravitational flow of cooled air. Here you can see in this picture over here, look at this picture. Here in this picture you can see the breeze is going down the slope into the valley, from the top of the mountain to the center of the valley. Here you can see also in this picture, it's going down the valley from the top of the mountain to down. So it's called as mountain breeze. The process in the evening on the night is reversed. The air on the top cools, on the mountain top, it cools faster than in the valleys. Warmer air in the valley rises and the cooler air on the mountain top moves down the slope. Yeah, the cooler air is going down. You can see from both the sides. Cooler air is going down to take its place over here. So this breeze is called as mountain breeze. From the top of the mountain to down the slope. Top of the mountain down the slope. It's called as mountain breeze. So students, you have understood about mountain breeze and valley breeze, right? Now we'll go to the next part, which is sea breeze and land breeze. Sea breeze and land breeze. Now most of you have been to a beach, right students? Right? Most of you have been to a beach. I'm sure of that. Now when you go to a beach, sometimes you go during the daytime. Few of you might go during the night time, right? Or evening time. Now if you go during the day, it's warm. You feel a little cool breeze. See, during the daytime over here, it is warm. You feel on the land when you're on the land standing here, you feel a little bit warm. You feel the warmth. But you also feel a cool breeze flowing towards you, right? Now if you go during the night time, it is cool, but you feel a little slight warm and cool breeze, mixture of that, right? You feel little bit warm and cool breeze when you go during the night time. Why is it so? Do you know why is it so? You feel that during the daytime different, nighttime different. Now we will learn about this in this video of sea breeze and land breeze. Pay attention, students, very important.
Have you ever been to a sea beach? Well, sea beach is a very exciting place. There are waves coming from the sea, and then there is the breeze which comes from the sea sometimes and sometimes from the land. And that breeze really gives you a great feeling all the time. Now, have you ever wondered how does this breeze happen? So how does the sea beach always have a breeze? Why is air flowing all the time on a sea beach? Well, there is a particular reason for it. I'll explain. So, this is the sea and this is land. Now, both the sea and the land have very special features. Now, the very special feature of land is that it gets hot very quickly. And as soon as the heat goes away, that is, as soon as the sunlight goes away or the sun rays go away, then it gets cold very quickly again. So, land gets hot pretty fast and gets cold pretty fast too. Now, what about the sea? Sea has a special feature again. It takes a long time to get hot. And then, once it is warm enough, it takes a long time to cool down again. So, both warming and cooling takes a long time in case of sea because it is filled with water. So, you see, both of them are side by side, that is adjacent to each other, but they have very different properties. These properties allow the breeze to happen. So, let's see how it works. So, this is what happens in the daytime. So, what happens in the day? In the day, due to the sun's rays, the land gets pretty hot very quickly, while the sea takes a lot of time to get hot because it is a property of sea that it takes a lot of time to get warmer. So, in the daytime, land is very hot and sea is much cooler. So, what happens because of this? Because of this, the air which is near the land also gets hot because it is in contact with land. And as the air gets warm, it rises up. And when it rises up, then air from here, which is a cool air. Now, why is it cool air? Because the sea is cooler and the air near it is in contact with sea. As a result, this is cool air. So, this cool air comes and takes the place of that warm air which rose up. So, cool air comes here and warm air rises. And as it rises and reaches here, so here sea is cooler, it gets cool and descends here. And then again, it comes here taking the place of the warm air. And this circle keeps on continuing in the daytime. And as a result, we have cool sea breeze coming from the sea continuously in the daytime. But in the night time, the conditions reverse. Let's see how. So at night time, again, there are no sun rays. As a result, land gets cooler pretty fast because it is its property. Land will get cool very fast as soon as the sun rays move away. So land is cooler and sea is warmer because sea will take a long time to cool down also because that's what is its property. So right now at night time, this is warm and this is cool. That is, the sea is warm and land is cool. Now what happens is, all the air here which is in contact with land is cool because land is cooler. Now all the air here which are in contact with the sea is warm because sea itself is warm and the air coming in contact with is also warm. So what is happening? The warm air above the sea is rising, and as it rises, the cold air from the land takes its place, and this warm air comes here towards the land, and when it comes to the land, what happens? Again, it gets cooled because of the coolness of the land. So it descends and then again moves to the sea. So constantly the air is moving from the land to the sea, and then we have the land breeze. So in the daytime, air was moving from sea to the land, and we were having the sea breeze. And at the night time, air is flowing from land to the sea, and as a result, at the night time we have land breeze. And that's how all the time continuously we have a breeze flowing on a sea beach. In the daytime it is the sea breeze, and in the night time it is the land breeze. So you see, the entire time when you are on the sea beach, you have constant flow of air or breeze. That's because all the time the air is circulating. So in the daytime it's circulating in this direction, that is, the land is warmer and the sea is cooler. So cool breeze is coming and the warm air is rising, and then again it takes its place continuously like a circle. And similarly at night time, the sea is warmer and land is cooler. So the opposite thing happens, that is, warm air from the sea rises and cool air comes from the land to take its place. As a result, we have the land breeze. So we have cool sea breeze in the daytime and cool land breeze at the night time continuously on a sea beach.
Now students, you have learnt about sea breeze and land breeze. Alright, I hope you have understood this. Now let's go to the next part. Now we will learn about seasonal winds, also known as monsoon winds. Monsoon winds are generated due to the uneven heating of land and water in different seasons. You have already seen in the previous slide about sea breeze and land breeze and how there is the uneven heating of the breeze. Right? Now, what are these seasonal winds? The winds that blow from a particular area towards a particular region in a particular direction. Now look here and look here. Now during summers, the monsoons blow from the sea to the land. From the sea to the land. Here so you can see in this picture over here, figure 5.6, seasonal winds from the sea to the land during the monsoons. The monsoons will blow from the sea to the land. And during winters it's the opposite. They blow from the land to the sea. From the land to the sea. You see, they are called as northeast monsoon winds. Here so you can see from the land to the sea. From the land to the sea. During winters they blow from the land to the sea. Now examples are in Southeast Asia, East Africa, North Australia. These winds are felt. Which countries? Which places? Southeast Asia, East Africa, North Australia. Here you can see in these two pictures over here. This is the equatorial low pressure belt over here, and this is the mid latitudinal high pressure belt over here. I hope you have understood this part, students. Now let's go to the final and exciting part of this lesson, which you are going to love it. We will lastly watch and learn about cyclones, hurricanes, cyclonic storms. Have you heard about these, students? About cyclones? Maybe you must have seen some movies and all, right? Cyclones, they move round and round. Tornadoes, you must have heard of these words. Maybe you must have seen in some movies, right? Now we will watch it and learn how they are formed, how the cyclones are formed, hurricanes and cyclonic storms, right? Watch closely. How are cyclones formed?
Cyclones generally occur in three stages: tropical cyclones, severe cyclones, and supercyclones. When the storm in a cyclone blows at a speed of less than 74 miles per hour, it is called a tropical cyclone. When it gets intense and the speed is between 75 to 120 miles per hour, then it becomes a cyclone or a severe cyclone. When the speed increases for more than 120 miles per hour, it becomes a supercyclone. How are these cyclones formed? Where are they initiated? Hurricanes, typhoons, what are they? Let's see. By the way, don't forget to subscribe to DNA so that you don't miss out any of the new videos that we post. Cyclone is a general term used by meteorologists to describe any rotating, organized cloud that originate over waters. Cyclones, hurricanes, typhoons, one event but different names depending on the location. In the Atlantic and the Northeast Pacific, it is called hurricane. And in the Northwest Pacific, it is termed as typhoon, and in the South Pacific and Indian Ocean, it is called a cyclone. You can also classify them based on hemispheres, the northern ones as hurricanes and the southern ones as cyclones. There are also a few other differences in them apart from where they originate, like the cyclones are usually clockwise, but the hurricanes are usually counterclockwise. Where do these cyclones originate? When the atmospheric pressure is low over a large water body that is still and the temperature of the water is more than 26.5 degrees Celsius, then they form into a cyclone. Before getting into any deeper, let us understand what is atmospheric pressure in general terms. The density of air in our atmosphere differs from place to place. They are not the same everywhere. Atmospheric pressure is the weight of air acting against the surface of the earth along with gravity. Air in the atmosphere creates a pressure on Earth's surface called the atmospheric pressure. Atmospheric pressure is more on the Earth's surface, and as we move upwards, there is less amount of air and hence the atmospheric pressure decreases. When there is low atmospheric pressure on a large water body on Earth's surface, they turn into a cyclone. This process of thin air circulating, strengthening and developing into a cyclonic formation is called cyclogenesis. So how does it become a huge, stormy, cloudy cyclone? When the atmospheric pressure is low, the warm air rises to fill the gaps and the cold air goes down as they have moisture in it. The warm air, as it reaches the place, it becomes more warm and it rises rapidly, thus creating more gap. So the surrounding air rushes in to fill the place. These filling air travels at greater speed and from longer distances. When they reach the area, instead of filling the gaps, they start circulating and thus creating a spiral. After that, any air traveling to fill the gap has to join the spiral because the air cannot pass through the spiral directly. Usually, tropical cyclones range from 100 kilometers to 2000 kilometers in diameter. When a large amount of air is rushing in to fill the gap, they form huge cyclones and the spiral structure becomes larger and larger, penetrating the clouds and thus creating thunderstorms. Tropical cyclones can grow up to a height of 10 kilometers and they last from 3 to 7 days depending upon the speed of the storm, how far it is away from the land and how big it is. Cyclones usually fade away or die when they cross the land area. There is a misconception that the buildings and the other interruptions on the land surface act as a barrier stopping the cyclone. But that's not it. When the cyclonic storm crosses the land surface, the main source of the cyclone, that is the warm water, is taken away. Cyclones work with moist, warm air. So when it crosses a cold water surface or a land surface, they die. Since 957 AD, that is for almost 1000 years now, there has been at least 11,982 recorded tropical cyclones in the Atlantic, Pacific and the Indian Oceans. And so far, the largest ever recorded is the typhoon Tip that occurred in 1979 in the South Pacific Ocean near Philippines, which was 2,200 kilometers in diameter with a wind speed of 190 miles per hour, that is 305 kilometers per hour. It lasted for almost 20 days, and this is said to be the largest and the strongest cyclone ever recorded in the history. For more informational videos on science, technology and history, subscribe to DNA.
Now before I show you this video, let me tell you students, what you see in this video is very real and performed by real people, means they are professionals. So that's why they go out in the storm. I don't want you to go out in the storm when there is a storm or a cyclone, alright? You should remain inside your house in the strongest part of your house. If you are evacuating the house, put off all the lights, electrical appliances, okay? Then only go out, but don't go towards the storm, alright? Let's watch the first one. It's about the tornado in Aurora, Nebraska. This was a massive tornado. Watch it.
We're inside it right now. Look at this. Look around, man. It's awesome. All right, straight left. All right, we gotta get out of here. Chris, look, we're in it. Here's popping. Taking right over. We're inside it right now. Look at this. Look around, man. It's awesome. All right, straight left. All right, here we go.
seen the real tornado cyclone. Now we will go to the anticyclone. Now what is anticyclone? In the northern hemisphere, winds blow in a clockwise direction, clockwise, whereas in the southern hemisphere they blow in the anti-clockwise direction. Now during anticyclones, the skies are clear, winds blow with lesser velocities, and the weather is pleasant. Now I will show you an anticyclone which is a clockwise, which happened in Calhoun, Colorado in the United States. This is an anticyclone in Calhoun, Colorado, United States, which happened on June 7, 2012. We have completed this anticyclone tornado. I hope you have liked it. Students, I know you have liked this today's lesson and part of the lesson. Today we have learned many different new things. We learned about local winds. In that we learned about valley breeze and mountain breeze. After that we learned about sea breeze and land breeze, right? Then we came to seasonal winds, which are the monsoon winds. Right, you have understood all this part, and then we learned about cyclones, hurricanes, cyclonic storms, right, and then the anticyclone, and you have seen the real videos. I hope you have understood this lesson very well. I hope you liked it and enjoyed learning. Thank you.